Hello everyone. Today we are going to discuss under application of Biot savart law, where we are going to determine the magnetic field due to a circular wire carrying current. Correct. For this, we consider an circular loop as shown by the radial circle here, carrying current I. Let I be the current flowing through this circle in anti-clockwise direction. We have to determine magnetic field at any point P at a distance r from the center of the coil O. Let capital R be the radius of the circular wire. We consider an elemental length dl on the ring, which is at a distance x from the point of observation P. Actually, the point P at a distance of x from the elementary length dl. Employing the Biot savart law, here we are using the Biot savart law. The magnetic field at point P due to the elementary length at A can be written as dB is equal to mu naught I, as I is the current flowing through the loop, by 4 pi dl cross x cap divided by x square, as x is a distance between the point P and the elementary length dl. So again, as the vector x is perpendicular to the elementary length is in this direction, so so angle between the dl and x is 90 degree. Thus we can write mu naught I divided by 4 pi dl by x square is pointing in, suppose this is a y-axis, this is a x-axis, this is x, this is a y-axis, is pointing toward this direction, suppose PR, where this is angle theta, this is equivalent to this angle theta, so is pointing toward PR direction, Now for the elementary length dl, if we resolve the magnetic field toward the x-axis, then the x component of magnetic field, the dBx can be written as dB vector of cos of theta, as this is the angle theta, so x component can be written as cos of theta. Similarly, y component can be written as dBy equal to modulus dB vector sine of theta. For geometrically opposite point, this is point A, the geometrical opposite point is point, this is suppose A dash. If we consider an elementary length dl at the geometrically opposite point, we will have dBx component which will be almost same as that of the earlier cases. This is dB cos of theta pointing toward the x-axis, and dB y component will be opposite of that of the dB vector toward the sine theta. This is the toward negative y direction. Thus, the component and toward the y direction cancels each other. So the remaining part is along the x-axis. So to find the total magnetic field, we have to integrate it. So total magnetic field B can be written as integration dB cos of theta. That is the x component only. So the dB component can be written as mu naught I divided by 4 pi dl by x square cos of theta. So from the figure we can write x square is equal to r square plus x square, and also cos of theta can be written as r by capital R by small r. If we replace cos of theta, we will get integration mu naught I divided by 4 pi dl divided by x square multiplied by r by this is actually is not x. This is basically capital R by x. So cos theta is defined as r by x. The cos theta is defined by r by x. So if we replace this term, we will get r by x. Thus, so as mu naught I is constant, so we are taking it out of the integration. We have 4 pi. So we will get r dl by x cube. As x cube can be written as so this part is same. So x cube can be written as small r square by capital R square 3 by 2 r dl. So this part we are writing here. So magnetic field B is equal to mu naught I divided by 4 pi r by r square plus small r square integration d of L. As here you can see the radius r is constant and the distance between the point P and O is also constant. So both small r and capital R are constant. So we can write like this. So only integration left over the dl part. So if this is the elementary length on the circular wire, that if we take the integration over dl, we'll get basically twice pi of r. This is the circumference of the circular wire. So it's r divided by is 3 by 2 left out here, 3 by 2 r square plus small r square divided by 3 by 2 multiplied by twice pi r. So if we simplify it, mu naught by 2 r square by r square plus small r square 3 by 2. This is magnetic field at a distance r. If we are asked to determine the magnetic field at a center of the wire, that is r equal to 0, we will get B equal to mu naught I divided by 2 is r by r square. This is basically r square plus 0 3 by 2. Which implies mu naught I divided by twice r. So thank you everyone. Thank you for listening.